Hello scholars and welcome to Fun Scholar. So today we are going to discuss the topic triangle and its properties. This is for class 7 C.B.S.E students, and this is an important topic because we also have triangle congruencies in our syllabus. So let's get it started. Okay, so the chapter name is triangle and its properties. So first of all, we already know from the childhood that triangle means this. That means a figure which is closed by three sides will be called as a triangle, just like this one. And talking about its real life applications or real life examples, and you know that every day part of the life we there are so many examples of triangles we get used to see. Okay, so let's know its properties. Okay, so let's start it. So a triangle is a closed figure with three sides, three angles and three vertices. Okay, so talking about closed, that like this one will be an open figure. This one will be, this is also a figure which has three sides. Okay, if I draw it a little bit like this, this is also a figure which has three sides, but this one is not closed. So that's why this figure won't be considered to be a triangle, but this figure will, because this is a closed figure and which has three sides. The sides are this one, and this one, and three vertices. So these three vertices are this one, and this one. So this will be considered as a triangle. Now it is one of the most fundamental shapes in geometry found in architecture, engineering and nature. Obviously in nature there are so many examples, and talking about triangle, which example comes in your mind? That will be maybe samosa, right? So let's go further and think about that what the triangles are. Okay, and this figure is like rotating it. So if I rotate a triangle, it will be form again a triangle, right? So let's go further, that elements of triangle. Now we have learned that what the triangle's definition is, and now we are going to discuss the parts of the triangle which makes of that any closed figure with three sides a triangle. So the first, in triangle's definition, I use the word sides. So the first one is sides. So talking about sides, the three line segments forming the triangle. So the three line segments, like I am talking about sides, so these will be considered as a sides, and these sides are all straight in line. Okay, so from this figure, the figure which are making it a triangle will be called as the sides. Okay, the next, angles, the three interior angles of the triangle. So angle means like something like cone. Okay, yes, cone is also an angle, and angle can be also called as the cone, and so many people in so many languages call angle as the cone. So these will be the cones. Okay, and in Hindi we call it kona, so it will be cones. And now the third one is vertices, the 3 points where two sides meets. Okay, talking about two sides, a triangle has three sides. Two sides are meeting here, two sides are meeting here, and two sides are meeting here. So these 3 points are making three sides meeting point. So these all will be called as the vertices. Okay, so now let's go further, that real life examples of a triangle. And what did I tell you before, that samosa is a very good example in our daily life of a triangle. Okay, But talking about samosas, samosas doesn't make really a triangle. Like it has some non-curvaceous shapes. So, but in real life there are so many examples where we find triangles. This one is pizza, this one is like a road signal, this one is a house, and this one is a kite. So these all are the practical examples where we found triangles every day. So there are so many, these all are written like road signs, kites and tents, triangle slices of pizza, roof structure of any house. So these all are real life examples. So that's why we are studying this chapter here. Okay. Now let's go further. Okay. Types of triangles on the basis of sides. So equilateral triangle, all three sides are equal. Okay, so talking about the examples of triangles, so by arranging them on the basis of the sides, we have three types of triangles. One is equilateral triangle, one is isosceles triangle, and one is scalene triangle. So talking about equilateral triangle, the triangle which has all the sides equal will be considered as the equilateral triangle. Like just like this one, you can, if you want to measure it like with the scale, with the help of the scale, you will notice that all three sides are equal. Okay, and now maybe you are wondering that, sir, what about the angles? Okay, and you have already learned about, if you want to try to draw a triangle just using this scale, maybe you won't be able to get the perfect shape, and there comes the angle. We will discuss it later. But first of all, you have to understand that a equilateral triangle has all the sides equal. Okay, I am not talking about the cone, or I am not talking about how can you draw it, but you can measure it like all the sides are equal, right? So this will be called as the equilateral triangle. We will further discuss it, that how can we draw it. Okay, but the measuring is pretty much simple. Okay, now come to isosceles triangle. Two sides are equal. Okay, this one is also that you can easily measure it with the scales, that there are two sides are equal and this side is non-equal. Okay, and how can you draw it? We will discuss it further, but currently just you get to know that this will be called as the isosceles triangle when the measurement of two sides will be equal. Okay, the third one is scalene triangle. All three sides are different, and this one you can just simply draw. Okay, you can simply draw this kind of triangle with the help of the scale. Okay. Maybe I am not able to draw with it. Let's think this one, and this one. Okay, a simple one, a simple triangle. This will be considered as a scalene triangle. You don't have to think about the angles about it. Okay, just you have to draw it the straight lines. Maybe this one I have drawn, which is maybe not, lines are not that much straight, but you can easily draw it with help of a scale in your home, in your copy. Okay, now come to the next one. Now the real life examples of a sideways triangle like equilateral triangle, and a very good example of any triangle or any three-dimensional figure of a triangle. Look, first of all, you have to understand that the triangle we are studying current now, that is a two-dimensional figure. Okay, that means that only one side will be visible here, and I am not talking about 3D and three-dimensional figure, which they are like for grown up. You have to grow a little bit for like class 9 and 10, then you will come to know about the 3 dimension of any figure. But let's think about the 2 dimension, and talking about 2 dimension, pyramid is a very great example of triangle. Okay, but if I consider it with a 2D image, okay, I am not considering it as a 3D image, I am just taking 2 different triangle from it. So this will be considered as a great example of equilateral triangle in our real life. And talking about isosceles triangle, kites are good example of isosceles triangle. Okay, maybe kites, maybe you have seen there are various types of kite. This one is also be a kite, but this one is not isosceles triangle. This one is good example of isosceles triangle, and similarly we are considering the 2D figures of it. Okay, and the scalene triangles are bridges, irregular triangle points, and there are so many. Okay, so these are the real life examples of different kind of triangles side based. Okay, now let's go to the next. Okay, so type of triangles on the basis of sides. Sorry, this will be angles, not sides. Okay, so acute angle triangle. So by arranging them with the angles, we will have three types of triangles. Those are acute angle triangle, right angle triangle, and obtuse angle triangle. Okay, so talking about acute angle triangle, all angles are less than 90 degree. Okay, and talking about degree, how can we measure? We need a protractor to measure any kind of triangle. Okay, currently I don't have a protractor right now in nearby in my hands. So to measure it, you have to put a scale here, and then you have to have a protractor which will measure them, and generally the 90 degree is like this one. Okay, and you can just say by looking at the image that if this one is 90 degree, so these all two angles are making less than 90 degree. From this side, this angle will be less than 90 degree, and from this side, this angle will also be measured as the less than 90 degree. Okay, and from the upper side, this one is also be less than 90 degrees. So all the angles when measures less than 90 degree will be considered as an acute angle triangle. Okay, so this one is an example of acute angle triangle where all the angles are less than 90 degree. Right, now let's come to the next one, that is right angle triangle. And talking about right angle means 90 degree. Right angle is 90 degree, and what I have told you, I am telling you that this one is the 90 degree. So the right angle triangle which will measure one angle as 90 degree will be called as the right angle triangle, and this image is similar to this image, and this is a very pretty much obvious or the easiest one, the easiest angle which you can draw, that is the right angle. Okay, but how can you draw it? We will discuss it later, but you can just draw it with the help of a scale. Maybe that won't be that much accurate, but you can draw it with the help of the scale. Okay, let's go to the next one, that is obtuse angle triangle. And obtuse angle is just the opposite of what acute angle triangle is. So acute angle triangles, in acute angle triangle all the angles are less than 90 degree, but remember only one angle, if only one angle measures greater than 90 degree, that triangle will be called as the obtuse angle triangle. And talking about greater than 90 degree, if 90 degree is measuring like this and acute angle is measuring like this, okay, so obtuse angle will be considered to be the greater than, that means that line will surpass the 90 degree angles measurement. Okay, so the obtuse angle triangle will be measured like this. Okay, just similar like this figure. Okay, here it is measuring greater than 90 degree. Okay. Now let's go further. Okay, so there are some real life examples of angle based triangles, that is acute angle triangles are roofs of houses, mountains, etc. Right angle triangles are stairs, ladders leaning against the wall. That means ladders are the perfect example of right angle triangle in our real life. Okay, and right angle triangle, we will consider this type of triangle pretty much in our next type of questions. And obtuse angle, that some bridges design stands. Okay, these two are less used, but this one will be used pretty much in our syllabus and in future also. Okay, let's go to the next one. Now, perimeter of a triangle. Talking about perimeter, the sum of the lengths of the sides of a triangle will be called as the perimeter. So that means that if I draw a triangle, the sides of this triangle, the measurement, the measurement of the sides, of the length of the sides will be added, and that will be called as the perimeter. Okay, so here if I am measuring A as this side, B as this side and C as this side, so the perimeter will be A plus B plus C. And maybe you all guys have learned about it. Okay, so here we will apply this formula and study it further. Okay, so the formula will be A plus B plus C. Next, do a little bit of sum. This one is pretty much simple one. You just guys can solve this question with your mental math. That is, a triangle has sides measuring 7 semi, 9 semi and 6 semi. So, find the perimeter of the triangle. You just have to do is just add 7, 9 and 6 and the answer will be 22 centimeter. Right? This one is pretty much easy. Another sum, the sides of a triangle are 12, 15 and 10 meter long. What is the perimeter of the triangle? So, the perimeter will be addition of all three sides and the answer will be 36 centimeter. Meter. Okay, the next is medians of a triangle. A median is a line segment joining a vertex to the midpoint of the opposite side. A triangle has three medians. Medians intersect at the centroid, which is the triangle's center of gravity. Okay, so let's discuss about it. Okay, so if I draw a triangle, it will be this. So these three all will be the vertex of this triangle. And talking about medium, starting from the vertex and ending in the opposite side's middle point will be called as the median of that triangle. Okay, and talking about median, there are three medians in a triangle obviously. So if you start from any vertex, it will cross about like this. Okay, and this point will be called as a triangle has three medians, you guys may have understood, and medians intersect at the centroid. So this point will be called as the centroid, and which is the triangle center of gravity. I will discuss about this point later, that what they are talking about center of gravity. Maybe you guys have learned about this word in physics, but for a triangle this will be called as the center of gravity or centroid. And there is the important property of the medians, that these three medians will intersect in this midpoint, right? And they have to intersect in the midpoint. So these are the discussion about the medians. Okay, so next we have to watch a video. So let's watch a video here. And talking about video, you guys may have know that I don't playing all the videos here. I will play the important ones, and the rest of all you guys can watch in your home peacefully. Okay, so let's start the first video, that is medians. Okay, so what we have learned about this, learned from this video, that there are midpoints, which is it will, if this one is triangle and A, B and C are the vertices of this triangle, and if we draw a line this will come to the midpoint of this one, and there will be three medians, and they will be crossing at this point, which will be called as the centroid. Okay, so and this one, yes, just like this, and this one will be called as the centroid or the center of gravity. Okay, and what I have told you before, that center of gravity, that means, okay, so if these two are triangle, this one will be called as the equilateral triangle, and this one is an example of isosceles triangle. Okay, and it will have a center of gravity or the centroid if the medians of this triangle intersect each one in this point. Okay, from this one to this one, this one to this one, and this point to this side. If we are talking about centroid, if we just put a hole into it, and this will be rotating in this point. If you want to hole in it in this point, the rotation will be a little bit difficult. Okay, so what we are talking about, that center of gravity means you have to just use force in the midpoint of a centroid to control the whole figure. Okay, these all are the concepts of physics. Okay, we won't be discussing that much in here, just but talking about center of gravity, what does it means actually? That center of gravity is a point where all the mass of that figure is being infused with. Okay, so and it plays a pivotal role in all kinds of in physics and mathematical explanation of the physics. Okay, and you guys can read it further in your physics chapters as well, but this is just a little explanation of this theory. Okay, so it's being done. Now talking about medians, we have already learned about it, and now we will watch some simulations about the median of a triangle. So let's see this one. Okay, I am playing it a little bit later. So let's learn some real life applications of medians. So balance in bridge structures. So if this one is a bridge, you can already see that there are so many medians are here. This one is a triangle, and the center of gravity, which I have being told that center of gravity will be in these points, and from this one this triangle will be controlled by the uses of medians. Okay, this one is very much ancient technology, that how can we structure a bridge. Okay, so this is the simple structure of bridge where the theory of medians can be used, or they are using it from the very beginning of time. Like this one is a bridge, you can see that they have used the ice cream sticks to build this one. And talking about the real bridges like this one can be called as like the Howrah Bridge, which is also a cantilever bridge, but they have also used the theory of medians in there. So the support beams in the construction, like every home, they have support beams which goes by the theory from the medians, and designing symmetrical patterns and also the bridges. Okay, so these all are the examples where medians are being used. Okay, let's go to the next one. Now we will discuss about what are the altitudes of a triangle. An altitude is a perpendicular line segment from vertex to the opposite side. A triangle has three altitudes. Altitudes intersects at the orthocenter. Okay, and talking about altitudes can also be considered as the height of any triangle. And you can, maybe you are wondering from watching the figure that medians and altitudes are the same things, but actually they are not, and we will discuss, and why they are not we will discuss it further. That altitudes, that means that perpendicular line segment from a vertex to the opposite sides. Yes, it has similarities with the medians, but it's actually not. So where altitudes are intersecting, the point where medians were intersecting, we are calling it centroid, but we will call this as the orthocenter. Okay, and this also has so many features which we will be discussing it in later. And altitudes, a triangle has three altitudes. This is also the similarity with the medians, and this will be same as the, and drawing of altitude will be same as the medians. But talking about the differences between altitudes and medians, we will be discussing it later. There are types of triangles which altitudes can be drawn, and there are types of triangle where medians can be drawn. Okay, there are so many examples where altitudes and medians both can be drawn, but the center of gravity and or the centroid and orthocenter will not be in the same places. Okay, we will be discussing it later. Next, go to the next one. Okay, so it has a video. Let's watch the video again because this one is important pretty much. So let's watch the video.
Consider any triangle, say ABC. What is an altitude?
Okay, so what we have learned from this one, that yes, and talking about medians, so this one may be clear a little bit doubt of you guys, that we have to draw medians from a point to its midpoint or like here. But talking about altitude, we have to draw a perpendicular. So a perpendicular will be drawn like this. Okay, so the perpendicular means 90 degree, and you can draw it with the help of protractor and with the help of any normal pencil and compass, and we will be discussing it how can we draw about it. But talking about medians and altitudes have to be a perpendicular. That means the cone between them have to be a 90 degree cone. Okay, and generally we use this sign to showcase the 90 degree cone of it. And like from this triangle, if I want to draw a median, so median should cross here, okay, in the midpoint, but they have drawn the perpendicular which will be crossing here. So the point of altitude and medians will be different. The point of intersection for three medians of this triangle and the three altitudes of this triangle will be different. So the centroid and the orthocenters space will be in a different point, right? So let's go further, and they have just drawn all the perpendiculars here. So the orthocenter will be in this position, and if they have drawn the medians will be maybe in this position. So their positions won't be together and they have different positions. Okay, so let's go further to discuss about it. And so what we have learned, that what are the altitudes of a triangle, and let's see some real life examples of altitudes where we will be using altitudes, like used in designing roof trusses, stability in the construction projects, and found in aeronautical engineering. Okay, and altitude has so many examples, like in height and distance. Okay, maybe you have learned about this in mathematics. Height and distance is an important topic, and aeronautical engineering means in like the measuring the lighthouse distance from this boat. So here they will be using the theories of the altitude to measure this one. And how they are measuring it, yes, we will be doing some maths regarding this. Okay, now learn. Okay, so this one may be clear, and we also has a simulation in it, and maybe we will be watching the simulations here in further. So let's watch this one. Okay, so exterior angle property of a triangle. An exterior angle is formed when a side of a triangle is extended. Okay, so from the beginning we all have learned the definition of a triangle, all the parts of a triangle, and all the types of a triangle. Now we will be looking for some properties of a triangle. The first one is exterior angle property of a triangle. Talking about exterior angle, so a triangle is like this. Okay, so if this one is a triangle, the angle of these triangles are this, but they all stays inside, so they will be called as the interior angle. Okay, but if I extend all the sides like this, so these all will be called as the exterior angle, just like from this figure. Okay, they have just extended, ABC is a triangle, and they have extended the BC side up to D, where it is making an exterior angle, which will be called as the angle ACT, right? And talking about the properties or the exterior angle property, which will be an exterior angle is formed when a side of a triangle is extended. Obviously they have extended it, and the exterior angle is equal to the sum of two opposite interior angles. Okay, so that means the measurement of this angle will be sum of this angle and this angle, right? So it will be sum of angle A plus angle B will be the exterior of angle C, or we can say it angle ACD, right? Okay, so completed. So what is the relation of an exterior angle of a triangle with its interior angles? Okay, so this video is important one, so let's watch the video here. Okay, so from this one what we have learned that this one is a triangle and we have extended it to make it a exterior angle, and ACD is making an exterior angle of it, and ACB are the interior adjacent. So ACB is an angle and the adjacent angle, or they are adjacent it, that is the ACD will be the exterior of adjacent angle. Okay, and ABC and ABC and BAC are the interior opposite angles of this angle or maybe this angle. Okay, and if I name them angle 1, angle 2 and angle 3, and their sum, we already know that the interior angles are 180 degree, and so 3 and 4 will also make a linear pair whose sum will be 180 degree. Okay, this one you may the measurement of any linear pair will be 180 degree, and this one is important for you guys also, that you have to remember this one, that they will all also be called as the straight angle or straight lines angle, and they will be measuring like this one. Okay, the measurement of a straight line or the angle between the straight line or the midpoint of any straight line will be 180 degree. Okay, and they will be called as the linear pair. And further of this, so angle 1, 2 and 3 are making 180 degree, and angle 3 and 4 also making 180 degree. So from this given condition, we can also cancel out angle 3 and angle 3 to make it angle 1 and angle 2 similar with the value of angle 4. So this is a theorem, or this is a condition which has been proved like this. Okay, so from this one what we have learned, that the extension of exterior angle of any triangle value will be similar as the sum of the opposite two interior angles of that triangle. Okay, so it's being completed. Now let's go further. Okay, so we also have some examples of this exterior angle triangle, and it has also videos. I am not playing it here, and you guys can watch this peacefully in your home. So now let's watch mathematics or some sums of this exterior angle property. Given a triangle with angles 40 degree and 50 degree, the exterior angle will be 90 degree, right, like this one. Okay, if these two angles are 50 and 40 each, so this angle will also be 90 degree. Okay, and if this one is 90 degree, this one will also be 90 degree, because this is a linear pair. Okay, right. The next, so now see some real life applications of exterior angles. Okay, hinges of doors and windows and mechanical joints or in cranes. Okay, so these all are the examples of the exterior angle triangle property. Okay, you may have wondering that how they are the examples of this one, but in actually if this one is making a triangle here, so they have to go by that logic to make all things happen. Okay, and this also works for hinges, okay, like for in door or in locks. Okay, so let's go further. Okay, so now we will discuss the angle sum property of a triangle, and we already have known about this. The sum of the three interior angles of a triangle will be always 180 degree, right? Will always be 180 degree. Example, if two angles are 50 and 60 degree, the third angle will be 70 degree. Okay, so this one is the simple explanation of angle sum property of a triangle, right? And we also has a video which you guys can watch peacefully in your home. I am not playing it here. So another video, that is how does the sum of angles of a triangle measures 180 degrees, and sum of angles of a triangle and example. So all these videos you guys can watch in your home. So before going that, let's watch our simulations here. Okay. Okay, so first watch the median of a triangle. So, if this is a triangle, now cut out triangle ABC. Okay, so the first step will be triangle. So, where we are drawing all the medians of this triangle. The second step will be if this is a right angle triangle, the perpendicular bisector of this triangle. So, this one is a triangle where they have drawn all the perpendicular bisect. Okay, so those are BL, AM and CN. And talking about perpendicular bisect, so what they have did in the first place, they have just drawn the straight lines from a point to the opposite sides to make it a median. But in the next step, what they are doing, they are just taking the perpendicular bisects of all these lines. And the third steps, join midpoint opposite vertex, join AD, the line segments AD is the median of the triangle connecting the midpoint of the BC to the opposite to the vertex. Okay, so these all are the medians of this triangle, and similarly the point where all the points are intersecting will be called as the centroid, right? Okay. And all the medians will be BL, CF and AN, right? Now let's watch the exterior angle of a triangle and its property. Okay, so the first step is to draw a triangle. Okay, we have drawn a triangle and which has three sides. And now we have extended it to make the exterior angle of this triangle. Okay, and talking about adjacent angles, so these will be called as the adjacent angle of this triangle. Okay, and which is also being called as the linear pair, and yes, which we have already discussed that the exterior angle will be these, sum of these two angles will be the exterior angle. Okay, right guys? And now we also has another theory of it, that interior opposite angles is the sum of two interior opposite angle will be the same as the exterior angle, and they have just using it different kinds of triangles to make it happen. Okay, so to prove it in every corner. So we have PQR where PRS is the exterior angle. We have to show that PRS is equals to RPQ and PQR. Okay, so to prove this one, yes, this one is 90 degree and this one is 40 degree is being given, and this one have to be 130 degree. Okay, to make it happen, right? So let's go further. So these all are the simulations by which we can showcase all the properties here. Okay, now real life applications of angle sum property. So used in surveying land, obviously the surveying lands are the examples where angle sum property is being used. Designing architectural layouts, constructing accurate triangular frames. Okay, so these all are the examples where angle sum properties is being used in real life. Okay, let's go further. So now this one is triangle inequality property. The sum of the lengths of any two sides of a triangle is greater than the third side. So this one is a very important one, that a triangle with 3 centimeter, 4 centimeter and 6 centimeter is valid because 3 plus 4 is greater than 6. So that means the sum of the lengths of any two sides, if you take this one and this one, their sum should be greater than this one, not equal to, it has to be greater than this one. Okay, if this one is 2, if this one is 3, this one has to be greater than 5, so it has to be 6, 7, 8, 9, whatever. So this is the triangle inequality property. Okay, and now let's watch a video. Sum of lengths of the sides of a triangle greater than twice the length of the joining vertex.
Let's try to prove something interesting using the triangle inequality theorem. Let this be a random triangle ABC. We have drawn a line from vertex A onto BC and let us name it AD. Note that D can be anywhere on the segment BC. We have to prove that the sum of all three sides is greater than twice the length of AD. Remember, D can be any point on BC. How do we do this? Let's write down what we need to prove. The sum of all three sides is AB plus BC plus AC. We have to prove that this is greater than 2 times AD. The moment we see such a problem wherein we have to prove that the sum of sides is greater than something, we should realize that we may have to use the triangle inequality theorem. So we can see two triangles here. Triangle ABD and triangle ADC. In triangle ABD, we can say that AB plus BD will be greater than AD. Sum of these two sides will be greater than this side. And in triangle ADC, AC plus DC is greater than AD. Why did we choose these specific combinations? It's because we wanted to have AD on one side of the inequality. We have two inequalities here, but first let's understand
Okay, so from this one, sum of all three sides will be obviously greater than the sum of any two sides. So from this one, we have to prove that sum of two sides will be greater than the value of the third side. So this is an important property of any triangle, that sum of any two sides has to be greater than the third side. Okay, so this has been proved in this video. Okay, let's go further. So this is an important property which is being used for so many kinds of work in our real life or daily life. So it's used in bridge and building constructions. As you can see that this is just a vector image where they have used the property, and from this one you can say that it won't make a triangle if we are not following this rule. There won't be any kind of triangle. Okay, you guys always can try in your home that if you want to make a triangle, just take 2, 3 and 5 as the sides, and you will see that if you are taking these sides as the 2 and this side as the 3, this side will have to be greater than the 5, and you will definitely see this one. If you take 10, 12 and 20 centimeter of these three sides and want to draw a triangle, you will see that there is no possibility that the triangle could make it happen. Okay, it will have some gaps into it to make it a triangle. Okay, like this one, it has all the three triangles, all are the triangles, and the important thing in all these images that the sum of any two sides will be greater than the third one. Okay, let's go further. Okay, that is right angle triangle and Pythagoras theorem. Yes, this one is very much important, and you guys may have known the name of the famous Greek mathematician or the scientist, that is Pythagoras or Pythagoras. Okay, so the theorem of Pythagoras says that in a right angle triangle, the longest side is called as the hypotenuse, and the Pythagoras theorem tells that a square plus b square is equals to c square, where c is the hypotenuse. Okay, so let's explain it a little bit. So if I draw a right angle triangle like this, the biggest side of this triangle is this one, and this one will be called as the hypotenuse. And if I square the value of this one, it will be the squaring values of this one and this one. Okay, if I give you some examples of it, okay, just like okay, let's take a right angle triangle whose hypotenuse is 10. Okay, so and if I square it, 10 square means 100. So these two sides has to be 100 in their squaring values. Okay, so it will be like a thing 190. No, there that can be happen. Oh, sorry. Okay, take it as 5. Okay, I am just making it to make it a whole number, and but you guys can try it with any number. So if you take a 5, the square of 5 will be 25, and if you take these 3 and 4, the square of 3 will be 9 and square of 4 will be 26, so the value will be 25. This one I have took because these are all the whole numbers, but if you want to take it as, if this one is 2, so all these two measurement will have to be same as 100. Okay, so just like say if you want to make 10 square, that is 100, you have to take anything like 60/40 to make it 100. and taking as 60, if you root over it, okay, if you take square root of 60, so that won't give any whole number. So that's why I have took all the whole numbers here. Okay, so this is the basic of the Pythagoras theorem. Okay, let's go further and see it here. Okay, so we have a video of Pythagoras theorem which I have already explained it to you. So now let's go further. Okay, maybe we will be playing the video later. Let's see some examples first. That examples of Pythagoras theorem that which we have already learned in the altitude chapter, that height and distance. Yes, this is some prime examples of how kind of height and distance sums can be done. Like if we have to measure the height of this figure, then we will have to draw a right angle triangle where this one will be the right angle and this one will be another cone, and we have to measure the hypotenuse of this triangle, and by this method we can find the value of this one or find the value of its reflection in this one, right? Okay, let's go further. That examples of Pythagoras theorem, yes, ladder leaning against the wall. This one is a prime example where the Pythagoras theorem works. You guys may have seen the any kind of like construction guys or the electrician guys, when they put a ladder into the wall, they have to set the base as a fixed point. Okay, if you want to cross the ladder in the less point, so it won't be valuing the Pythagoras theorem. Okay, so if you want to get the maximum results, you have to take the ladder in a fixed position to reach any kind of like to reach this point. You have to keep the ladder in this fixed point to make it a right angle triangle. If you can't do this, if you take ladder at like this point, the ladder will get slipped. Okay, so this is not following the Pythagoras theorem. Yes, maybe all the people who works with the ladder, they may don't know the Pythagoras theorem yet, but in nature naturally works as like for these rules. Okay, if you want to keep the ladder like a little bit less distance from it, so maybe the ladder will get slipped. Okay, and the person who are working upon the ladder will get drowned, right? So let's go further. That is converse of Pythagoras theorem. Before going it, let's watch the video that how do we derive the Pythagoras theorem. So let's watch the video that how will we derive the Pythagoras theorem. Okay, let's see one video and the rest of the two videos you guys can watch it later. Okay. Okay, maybe this video was a little bit lengthy, so let's understand it a little bit better, that how Pythagoras theorem can be used to prove its theories. Like this one is a square, and if we fit another square into it, it will look like this. And from these 2 points we are getting there are 4 triangles from here. Okay, and they will be measuring as the same as this point, like this one is ABC, 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 ABC. Okay, so area of the outer square is a plus b, and that's whole square because we have to add them, and area of the outer square will be like this one, right? And now if we cancel out that, if they are the same square, their area will also be the same, and if we cancel this 2 out from, so then we will get the formula of Pythagoras theorem, that is hypotenuse square is equals to height square plus base square. Okay, this is the purpose of this video, to prove that how can we use the Pythagoras theorem and how can we derive, and how in the other parts of geometry we can derive the Pythagoras theorem. Okay, next learn about the converse of the Pythagoras theorem. So, and maybe we had the video that we have watched, that is the similar kind of the this the reverse, that the converse of the Pythagoras theorem will look like this. If in a triangle, square of one side is equal to the sum of the squares of the other 2 sides, then the triangle is right angle triangle. Okay, so from Pythagoras theorem we have learned that if hypotenuse square is same as the height square and base square, so that will be a right angle triangle, or that is exactly the Pythagoras theorem tells us. But in converse we also can tell that in a triangle, if we put like this one is a triangle. Okay, you don't have to consider the whole figure from it, you just consider the first point from it, though this is not a right angle triangle, but just think it as a right angle triangle. So if this is a triangle and we put a square which will look like this to its hypotenuse, and the 2 different other squares in the base and the height, so if the area of the square in the hypotenuse position like this is same as the area of the base and height part, the sum of their base and the heights part will be equal to the square in the hypotenuse part. Okay, if this is a right angle triangle, and if we put a square here and a square here and a square here, the area of this square will be the sum of the area of this square and this square. Okay, so this is the converse of the Pythagoras theorem, which is telling us. Okay, so let's revise it further. If in a triangle the square of one side is equal to the sum of the square of the other 2 sides, okay, so then the triangle is a right angle triangle. Or if we tell it like this, that in a right angle triangle the square of one side, the square of the hypotenuse will be equal to the sum of the squares of the other 2 sides. Okay, so the triangle must be a right angle triangle. So from this one we can tell that in a right angle triangle we will also follow the Pythagoras theorem, or in a triangle which is simply following this point will be same as the Pythagoras theorem. Okay, so this is the converse of the Pythagoras theorem. And next we will see that real life examples or applications of Pythagoras theorem, like construction of the staircases. Yes, the staircases is being constructed in a manner so that we reach our right destination, like this one. If you watch from like for a very big building, if you watch from in a upper or in a lower, you can see that there are so many triangles are forming in the shapes in the upper position. Okay, like in this image, it is a triangle which is being forming, and that is also a right angle triangle. Okay, so these are the real life examples where the Pythagoras theorems are being used. Okay, let's go to the next one. Yes, and the real life examples of a Pythagoras theorem. Yes, that's it. That the navigation and the GPS system. So in the navigation and GPS system, like these ones are the satellites and your phone, and this is the satellite, the satellite imaging system, where they are using the Pythagoras theorem or the simply triangle inequality to measure the distance, or maybe like the GPS. Like for GPS, like you guys can use the maps. So they are using just the simple technique just to measure from the satellites that how much time you will reach any kind of destination. Like in maps, you guys have seen that they have just that navigation point where when you are going to reach in any kind of destination. So they use the Pythagoras theorem or these mathematical obviously there are high levels mathematical theories to make our life better. Okay, so that's it for today. I hope you guys have enjoyed the video here, and this one is quite easy and quite crisp and quite enjoyable chapter was this, the triangle and its properties, and I hope I will see you in the next video. Okay, bye.